Hello.
Hello, good morning.
I noticed the lab's pretty short. It's just going to be walking through it with the class, right?
Yep, that's the plan. The lab is important in that if they get through it, they've done 90% of the homework problem.
Yep. Okay.
I'm about to make you the boss, and then I will admit actually as host, you can go ahead and turn off the waiting room, let everyone in.
Okay.
Recording is running right now.
All right. Should do it.
Yep, you got 5 minutes. I think you'll get more in a few minutes.
Okay. It's 9:02. May as well get started. So is everyone able to see my screen? Okay. You already were expecting that. Good job. All right. So today's lab, if you haven't already looked through it, is relatively short. So, and it's also pretty empty. We need to fill out all this stuff. So that's what we're going to be doing. It's going to be a group project of getting all this filled out. So what are we doing today? Well, I mean, what's the task we're trying to do? We have some data in the form of CSV. Looks like this. And there are a bunch of measurements in it. And what this data is some measurements of runoff and water behavior in can't remember exactly where in Texas, but what this data is for is, okay, we've looked at the last couple of years of how, river levels and stuff like that, flooding, everything taken here. And we want to be able to say, all right, this river it flooded the last 3 years, or flooded, let's say 6 of the last 10 years. So we should have a decent expectation that it may flood. So we want to be able to use past data to predict the future. That's really what we're doing here. So let's get started with that. First thing we're going to do is get our CSV, make sure it's downloaded and in your bay here. After that, we're here. So we want to make a data frame. And then we want to explore the data frame and describe it. So what packages are we going to need? The keyword to get them is import. So which ones do we need? This is going to be the whole lab. I have already ran through this and looked at the correct places to essentially copy and paste. And then I went back and deleted them so that we would know where to look. Okay, so pandas, yep, we need that one to do data frame stuff, and we're going to do data frame stuff. NumPy is probably going to be useful. Matplot, can't remember exactly the yeah, this. Okay. Well, these are the ones we normally use. So if we need more, maybe we'll need more. Okay, first thing we want to do is read the data file. Does anybody remember which of these libraries lets us do that? Or an acceptable answer would be, where should I go to look? That can be either in the form of the lesson, or you can tell me what to Google or what. Read.csv. Okay. This. I'm assuming that's a function. So I will watersheds.csv. Like that. I can always run it. The name read is not defined. So either I misinterpreted. Possibly. So we are in a spot that you'll always get to, well, not always, but a lot of times where you're like, I know there's a pandas thing for reading a CSV, but I can't remember exactly the syntax. So two options, really. Well, there's a bunch of options, but two good options. One is to Google where the documentation is. The other one is kind of what I did here. Is I know I did this earlier. So what I'm going to go back to some old code I had, and I'm going to copy it, and I'm going to paste it. But Catherine was on the right track, so good job. Okay. We're going to just stick with data because that's what was there. I need to change the watersheds name in here. And then I'll just, let's see, it might be large. So we're going to put the head method there just to make sure. I'd like to see if it worked. If I print the whole thing, it is at least enough to scroll down the page. It's not that bad. It's not 60 million, but see if it works. Okay, PD is not defined, which would, it's no big deal. It's just that we have to remember in the thing I copied it from, we put some monikers for NumPy and Pandas. So I'll go ahead and do that. PD and NP. Okay. All right. We've got data. We got something. That means it at least worked. Okay. So far, so good. Summarize the contents, and then we'll talk about them. So we need to explore the data frame. What are some ways we can do that? I've already used head, and what does that tell me? Well, there's 1, 2, 3, 4, 5, 6, 7 columns. Seem to be floating point numbers. That's not quite enough for me to say that's a brief description. So what else can I do to look at the data and give some description of it? Describe, yep. That's what I was going for. So let's see what that says. I'm actually going to put the data.head back because the describe method, or maybe I'm just crazy. Oh yeah, it needs to be in a separate cell. No big deal. Okay. So what I'll do is that. That way I can actually see data itself rather than just this stuff. Now, in previous times when we use the describe method, they look, at least in structure, really similar, which is unusual. And that's because most of the time when we handle one of these, there's text in there. So the describe is a lot smaller, but here it just so happens that everything's a number and we can deal with it. Okay. So we have pretty much everything we would want to look at in order to just give a description. So how would we describe what we see? What's our data? What's it got going on? What are the three most important things? Let's start with that. Okay, there's 92 entries. So okay, that's one of them. Okay. It just write the type of data. That's the second one. It just so happens that all of them are floats. What would there's one more thing I'd like to be able to say about, so there's 92 entries, all right? Each entry has a certain number of columns, and every one of those columns is a float. What's the thing I'm leaving out that would be really nice at a high level? Yeah, the number of columns. So we got 92 entries with 1, 2, 3, 4, 5, 6, right? 2, 3, 4, 5, 6, 7. Interesting. It isn't putting the station ID in there. I see. Anybody want to take a guess as to why? The station ID is not present in the describe. So this isn't actually correct. Right. We could look right at the hard data. There's actually a method to tell you the type of each column without having to actually reference the column. But it makes sense why if you look at what the data is trying to do, it makes sense that it's kind of not working as a float and it's not showing up in here. The station ID is a series of digits, but it's not intended to be numerical. It's intended to be, this is basically a string. And we can actually check to see if our guess on that is right. So I can do data station _ID, and just to make sure that works. Okay, and I can describe that. Actually, I don't want to do that. I want to do this. I want to print the type. I thought that would tell me a little bit more, but I can do this. I think, yeah, right there. So the what I did was I went to my data. I'm like, this isn't showing up in the describe. Why would it do that? Well, my feeling is that, oh, they're trying to just give it a name and they're just using numbers to do it. So I went and I got the first column, and then I got the first element out of that column, and I give the type. I can print the actual, oops, must be a, yeah. Yeah. So this is the string 0815 blah, 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 blah. If I were to try to do this plus 3, it wouldn't like it. Okay. So moving on. First column is a string. I'll say is of type string. Okay. So that's something, but we want a little bit more. So what more can we say about our data frame? Or do we want to say anything more? Thing we're asked to do is explore the data frame and briefly describe the summary of the data frame. Talk about the mean and the standard deviation. Okay, we can do that. Is there anything striking about the mean and the standard deviation of the numerical columns? Is there a pattern? Is there something worth, maybe the range is something we want to talk about? What more do we need to say about our data frame? Is it necessary to go back to the basic description we have? Not sure what you mean. Is it necessary to go back the past description we have? Not sure. Can we talk about how it may be distributed? We would need to look deeper in order to figure that out. Basically, since we're only talking about the data frame itself, in my opinion, this is pretty much good enough. I got 7 columns. First one is a string, everything else is numerical and a float. I might want to say what the data is for. You could not, I don't know. But I think it's, as far as describing the data frame, I think it's pretty good. I mean, we could talk about the mean, but it's a numerical column. It's going to have a mean. If I saw that the mean was 0 or it was a whole number, I might think, that's interesting. Like, I don't see anything crazy interesting. But I think it's pretty good. All right, so that's step 1. Step 2, we need to make a data model. And we're wanting to use the TDA, and we want to make that a predictor of the T peak. And here's the formula we'd like to use. So plot our model and the data on the same plot. Okay, what do we need to do? Define the function. Yep, that's something we need to do. All right. Can anybody tell me what kind of model this is? Well, I guess I'm asking for the name of the function. So what do we want to call a function? Linear model? Yep, that'll work. Okay. How many arguments is linear model going to take? Three, B naught, B1, and TDA. Very good. Very good. So we've got B naught, B1, and TDA. Okay, so what are we going to do with those things? What are we going to do with B naught, B1, and TDA? Now, I just put this ret val here because when I make a function, that's just how I started out. We don't have to use them. So according to, yes, actually, if I were to read your statement literally, I don't think that would be correct because order of operations says you don't add these before multiplying. It would say you multiply this one first, but other than that, very good. So we're going to say take B naught plus B1 times TDA. And due to the order of operations, I don't need to put any parentheses here. There's an implicit, the compiler knows to do this. Okay. So I could have put that on the return line. I may as well return that. Okay. So there's our function. Good. Now what? What's next? At some point, we're going to need to plot something. Show the plot. Okay. What's something else we're going to have to do? Run our data through the model. Yeah, we're going to need to do that. Run data through model. Okay. Is there anything else we need to do? Yeah, you're right. Good catch. There is one more thing I could say we need to do. Like this is a task. This is a task. There's one more task. Other things I'm going to say here are some subtasks like this. I want to say put data. How do I emphasize raw data into plot? Put model into plot. So these are saying we want to put the model and the data on the same plot. Okay. Run data through the model. I don't really need to elaborate on that, but there is one more thing when you error. What's the error? As someone pointed out, I forgot the colon here. Sum of squares. Oh, do we need that? We could do that. Yeah. Calculate error. With sum of squares. I could do that. That's not what I was thinking, but yeah, that's okay. What I was thinking, so we're going to put stuff into our linear model, right? Where is the actual numbers that we're going to put as the third argument? Right. It's the TDA column. Okay. What about B1? Where's that come from? Y-intercept? No, that would be B0, but that's not exactly what I'm asking. What do you mean by input? Yeah, so B0 and B1, the thing I was trying to get at is we need to pick those. We got to pick a good B0 or a good B1, or we have to come up with some method that'll guess for us. So we need some way pick B0 and B1. All right. All right, that's good. That's all we have to do. I guess I should put define our model function. Should have started with that. Okay, so we need to pick B0 and B1. How do you guys want to do it? We can't use the formula? What formula? Design matrix. I'm not sure what you mean. Hey, there's something that is a completely acceptable thing to do, is to say, hey, we did this already in lesson 24. So let's go look at it. It's actually what I did when I did this myself. So I was just waiting for someone to say it. All right, so this is the plot part. Here's where we start, I think. Yeah. All right, so this is what we already have done. We've made our function. We have our data in the form of a data frame. This is where we're picking our B0 and B1. This is just the black box plot stuff function. Here is where we're going to get our output prediction. So we're going to apply a function using B0, B1, and our input. And we're going to put the output into our speed list. All right. So this is the stuff we don't have. Let's see. I'll move stuff around so that it actually is in the spot we're talking about. Okay, so that's that. Run data through the model. This is going to go here. This can go, well, here. Okay. Oof. Okay. All right. So we have a process here that it'll work, but it doesn't work on the data we have. So we need to change that. Also, we got to rename some stuff. So let's see. Do we have to guess B0 and B1, or how we can we have it choose for us? We could. What do you guys want to do? So if okay, let's try letting it choose for us. Okay, I'm fine with that. Where can we find how to do that? Unless you just know it off the top of your head. It's in the lesson? Yeah, it is. It's down here, right? Okay. So the thing we're going to do is what's called interpolation. Huh. Yeah, I was just reading it. So is this where it actually is? Let's see. We just need this, right? Okay. So here, this will go here. Don't need that. Okay. So let's look. This is just the standard printing thingy. Got the title, input, output, input, our approximation. Okay. We can work with that. So when what we've done is we have a thing we got to do. And we know we've done it before in some other place with some other data. All right, so we went and we yanked out all that code. We arranged it in the way we think is going to work. And now we have a very important and sometimes difficult task of making sure we rename and replace everything from the old code to do what we want with our new stuff. Because this works on a list that's been defined right here. Not only that, it's got different functions and different names for things. So we need to go through, because if I run it right now, here's what's going to happen. Time's not defined. Yeah, it's not defined because instead of using a hard-coded list, we're going to be using our data frame. So we got to go through this basically line by line and decide if it's good or if we need to change it. So let's start here. I know this is a function, so nothing below. Everything here is in its own scope. There's nothing I need to change. What about this? Do I need to change the name of my function? Right. So Jackson's actually exactly correct. Hunter's not incorrect. But I would say Jackson is more correct. So here's what's going on. All this code is using this function right here. We could do one of two things. Every time we call our function, so I don't need this. I could get rid of it. Every time we call our function, like here and here. Interesting. We could replace it with linear model, or we can, and if we don't want to change these, we could change the name of this. So there, it's 6 one way, half a dozen the other. I am interested to see. So let's see, where are we? We're here. This calls polynomial function here, and it calls. Oh wait, no, this is something I copied earlier. We don't need this anymore, I don't think. Never mind, disregard. Okay. So we can either change the name here or change the name here. There is also one other thing. This function was expecting B naught through B2, and we don't have that. So we don't need that. I don't particularly care what we do. We'll just do this. I'll say polynomial. Is that okay? So I replaced their polynomial. I replaced their polynomial definition rather than changing the function calls. Doesn't really matter. Okay, so that's good. What about this? Oops. So this is the X matrix. The transpose is fine because this is just running the method. We don't need to do anything with that. But what about X itself? What do we? Is this okay? Change time to TDA. Okay, so I know what you're getting at, and I'll say we need to change the inputs that the old code is using to the inputs we're wanting to use. So they were using time and speed, and we're using TDA and tpeak. So let's do this. TDA is data. TDA. Pretty sure that's what we called it. Yeah. All right. So we can do this now. Yeah. That's what I'm doing. Now this is going to be a series. So time in the old code was a list. And so lists and series have very, very similar behavior. but I wonder if just plugging it in like this will work. So we'll know soon enough. I mean, if I run this, it won't be correct because I haven't gone through and done everything. But let's see if we get where we want. Well, we get past, as you can see, the execution got here, which means that this at least worked. It didn't break. So hooray for that. Okay, and speed. Here, what was speed defined as? It's the actual data itself. Okay, we can do that. It's kind of weird. There's a comma here, just trailing. All right. So I was thinking like I was going to do this. T peak is just an empty list, but I think if we just do data, T peak should be okay. All right, so everywhere I see speed, I'm going to replace it with that. Speed. Anyone else see one? Well, there's always the run it and see where it breaks method. Line 15, time is not defined, okay? This needs to be TDA. 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 I don't see any more. Let's see what happens. For ion range, blah, blah. Okay. All right. Well, we've gotten through all these because the compiler goes, I guess it's not a compiler. The interpreter goes in order. So we've gotten through all this stuff. So we've replaced and done all that. What about this? We got an error. Square is not defined. What the heck does that mean? I got an error, and I can't do stuff when there's an error in the middle of it. So what's wrong? Square is a function you made to square the error, which you have not defined. Yep, that's it. So when I see something like this, is not defined, well, either there's a variable or a function I'm using that I haven't defined. So I could have made a typo like I did before, saying like calling polynomial, or in this case, I'm using a function that I didn't define yet. So let's go see where it's defined. Just right here. Alrighty. Now I'm weird, I guess. I like having my functions defined at the top, so that's what I'm going to do. All right, so square error, take A, take B, A minus B squared, and return it. Works for me. Intercept is not defined. All righty, so this is actually good because we've gotten through all the calculation stuff. At least it ran. We don't know if it's right, but that means we put all the things in the right spot. Now here, this is the B1 and B0 that was actually used in the lesson. So let's go look to see where they were defined. So that's where is that? It's after the show. So I want the title thingy. Oh yeah, I was up here, wasn't I? Yep. Okay, so let's use this one instead, just because that's where we are. Okay, do that. Okay, so the example we stole from had it went all the way up to x squared. We don't do that. So we're going to get rid of that. Do we have x defined like that? What's x? Oh, okay, these are the guessed, the ones we start with. We do have to start with something. That is true. All right, then. I can just hit that button. All right. Let's see if it actually runs. Time is not defined. I missed one. Oh, right. This is saying we're actually using our print function thingy. It's function, but the reason I say function thingy is because it's a big block of stuff that you don't really know how it works. So this is going to be the input and output, input and output. So what needs to be the input and output for the first thing we want to plot? TDA. Okay, let's put it this way. We're plotting something versus something. So here we're doing TDA, and this is going to be tpeak. Okie doke. So this will be TDA, the actual variable. Yeah, look at that. You can just copy and paste. Okie doke. Interesting. Hey, we got something. What's this SE? All right. That doesn't need to be there. Hey, look, it's stuff. Might not be good stuff, but it's stuff. So, what do we think? Is this good? Make a data. Well, let's see. Did we actually do step 2? Make a data model using TDA as a predictor of tpeak. Did that. Plot your model and data on the same plot. Report your values of the parameters. Well, they're there. So technically, we did what it asked. Are our guessed? It's pretty erroneous. Yeah, it is. How might we make it a little better? I mean, it's not terrible. If we were only looking at this part, then I should probably change the color, shouldn't I? If we were only looking at this part, if I were doing it myself just by eyeball, it'd be kind of like that. And then for the rest of it, I mean, it's just this one here and this one here that makes it difficult. If it weren't for those, I would say something like that. So I mean, it's not horrible because take if I had to connect these two lines, it would be somewhere like right here, which is where the original blue line is. So it's not the worst in the world. But what I would do, we are out of time. So what I would do is I would tinker with these a little bit. I guess I don't need this one, do I? Because we're only going to for a linear model. Also, I would change this. Okay. Well, yeah, I would just tinker with these. Like I'll do one tinker. What do I think? 1.5. Okay, it changed. All right, so I've shown you how to do it all. We walked through it together, so that was pretty good. Thank you for the participation. It's not as fun when I have to just sit here and talk to a screen. Everything we did in step 2 is same thing for step 3. And shocker, this is exactly what you're going to have to do for your homework. All right, any questions, comments, concerns, math jokes? Yeah, I would say it's going to be pretty similar, even if you do tinker around with it. It looks bad, but it's actually not. And I guess something I should point out is, so if I were actually trying to get my guesses to be really good, or at least acceptably good, I'd copy this whole thing and I'd do it twice. That way I could see the change in action, because right now I have to memorize. So 2181438, right? 2181438. Okay, so it didn't change very much, which is to be expected. I didn't change it by a lot, but this is the error. I would try different numbers and I would try to get this as small as possible. Okay, then. Office hours tomorrow, and you can always email me with questions. So have a good one.